Today's objective will be to solve equations using the properties of equality. The mathematical practices we will focus on in this lesson are going to be number 3, to construct viable arguments and critique the reasoning of others, and mathematical practice number 8, look for and express regularity in repeated reasoning. Vocabulary. Number 1, open sentence. It's a mathematical sentence containing one or more variables. For example, 4x to the third plus 2, that's an open sentence, along with p to the third plus 2p. Number 2, equation. A mathematical sentence stating that two mathematical expressions are equal. For example, 2c equals c squared minus 8 is an equation. Number 3, open sentences are neither true or false until the variables have been replaced by numbers. Each replacement that results in a true sentence is called a solution. Let's look at an example of solving equations. First example. So I have an equation because I have two sentences, mathematical sentences, set equal to each other. So the first thing we need to do is eliminate these parentheses. So I'm going to use my distributive property to eliminate both sets of parentheses on this one side of the equal sign. So I'm going to take 5 and multiply it through the first set of parentheses, so 5x plus 15. I'm also going to do that on the second set of parentheses. Multiply a positive 2 throughout that set of parentheses, so 2 times 1 is 2, and then 2 times negative x is minus 2x, and then I'm just going to simply bring down my equals 14. Now I want to look at one side of the equals versus the other side and ask myself, can I combine any like terms before I proceed to eliminate and get the x by itself? So what I notice is I have a couple of like terms on this left-hand side. So what I can do is I can combine this 5x and this minus 2x together. So 5 minus 2, I get 3x. And then I also can combine my constants or my numbers. So that would give me positive 15 plus 2 is plus 17. And then I can simply drop my equals 14 down from the right-hand side. Now that I have my like terms combined, I can now work on isolating my x and getting it by itself. So I tend to think of reverse order of operations. So add and subtract first, and then multiply and divide to isolate this x. So what I need to get rid of are two things. I need to get rid of this positive 17 and this 3 that's multiplied here by the x. So the first thing I want to do is subtract 17 from both sides. Doing that, it eliminates this 17 because 17 minus 17 is 0. So we can cross that out. I can drop down my 3x, my equals, and then 14 minus 17. That does give me a negative 3. Now my last step is to eliminate this 3, and by doing so, that'll leave me the desired x by itself. So I can divide by 3 on both sides, because 3x means 3 multiplied by x, so the opposite of multiply is divide. So this leaves me a solution of negative 3 divided by 3, solution of negative 1. It might be a good idea for you to go back and substitute that negative 1 for x into your original equation and check that solution to see if this left-hand side does equal the right-hand side. Now it's time for you to pause this video and practice in your notes the following practice problem. Example number 2. What if there's a fraction involved in solving for a variable? Like in example number 2. Negative 5/8 x equals 20. So the goal is to isolate x and get x by itself. What I notice is that on the left-hand side of my equation, I only have negative 5/8 x. That means I'm multiplying this fraction times x. Nothing else is happening, so the opposite of a multiplication is a division. Well, let's think back to our properties of fractions. When you divide by a fraction, that's the same thing as multiplying by its reciprocal. So let's do that. So to eliminate or to get rid of this negative 5/8 on the left-hand side, I'm going to take the reciprocal and multiply on both sides. So I'm going to take and multiply. I'm going to take the negative with me. The reciprocal of negative 5/8 is negative 8/5. So I'm going to multiply that on both sides. So negative 8 over 5 times. Now, here's what happens. That eliminates the fraction because it cancels out to 1, and I would get 1x. So we can just drop this x down. And then two ways I can multiply this 20 and the negative 8 over 5. You can take 20 over 1 and multiply it by negative 8 over 5, which is fine. So numerator times numerator, 20 times negative 8, that's negative 160, over denominator times denominator, that's 5. Then you can divide, because a fraction is the same thing as a divide. So negative 160 divided by 5 will give you negative 32. That's one way. The other way would be to do some cross canceling. So I know that 20 divided by 5 goes into 5 one time, and then I can take 20 divided by 5 and get 4. And then I can simply multiply numerators together and denominators together. So 4 times negative 8 is negative 32 over 1 times 1, negative 32 over 1. Notice we get the same answer, two different ways. Makes me no difference how you want to proceed and multiply, just do what's best for you. So my answer would be negative 32 for x. So please make sure you substitute that solution back into your original equation. So back here we had negative 5/8 times negative 32. And then we want to put this in our calculator, so we'll pause to put that in there and check to see if that is equal to 20. It is now time for you to pause the video and practice number 2 in your notes. Next example, and this is an SAT type problem, and that's kind of why we're bringing it up at the moment. So if 6x minus 12 is equal to 18, what is the value of 6x plus 5? So what you need to do is ask yourself, what is the question I need an answer to? So that what the answer would be is the value of that expression 6x plus 5. So 6x plus 5 is equal to what? Now we kind of have to work backwards. In order to calculate the value of this, what we need to know is the value of x. How do we get the value of x? Well, look at what's given to you in the problem. 6x minus 12 equals 18. So based on our vocabulary words, we solve this thing for x that should give us a solution to this equation. Then we can plug that x in over here and get a value. So let's proceed. 6x minus 12 equals 18. If you'd like to divide your equation into two different sides, that's fine with me. If not, that's fine too. So let's solve this thing and isolate x. Again, reverse order of operations. Do I have any adding or subtracting that I need to do to get one step closer for x to be by itself? The answer is yes, I need to get rid of this minus 12. So since minus is already given originally, the opposite of a subtract is an add. So add 12 to both sides. This will add to 0, so that's why we can cancel that out. I bring my 6x down and my equals. 18 plus 12 will give me an answer of 30. Then lastly, to get x by itself, I'm going to divide by 6 because that is the opposite of this multiply. So then I get a final answer of x is equal to 5. Now that's not what the actual problem asks me to find. That's just one step closer to getting where we need to get. Given that x is equal to 5, now I can go over to what the problem is actually asking me to find, is the value of 6x plus 5. So now I'm going to substitute 5 in for x, and then calculate that value. So 6 times 5 is 30, and then 30 plus 5 is 35. This would be my final answer to problem number 3. All right, example number 4. in the past few examples, we have only had one variable that we've needed to find the value for. Now we actually have two variables. This is an important concept moving forward when we get into graphing equations of lines, because you might see this standard form of an equation, but you're going to have to manipulate this and solve it to get it in slope-intercept form, which will look something like y equals mx plus b. So let's practice this. So here's my equation, and I want to solve this thing for y. What works best for me is if I take and kind of circle or box or do something to the variable that I want to isolate or get by itself. So that's going to be my y. So I'm just going to put a box around it so I know that that's what I'm striving to isolate at the end. So there's two things we have to get rid of in order to isolate y. That's going to be this 8x and this negative 5. Okay, so again, reverse order of operations. Anything that's directly attached to your y, we're going to leave for the last step. So the first step would be to get rid of this 8x. Well, originally, this 8 is a positive number. So if I want to bring it to the other side of my equals, I'm going to do the opposite. So the opposite of adding is subtracting. So I subtract the 8x from both sides of the equals. 8x minus 8x, that's 0x, so that's why we can cross those two out. I drop down the negative 5y. Please don't forget to bring that negative down if that's still left. So negative 5y comes down, equals. Now it's very important if you look at slope-intercept form to notice that the x term goes before the constant or plain number. So for this, I'm going to put this negative 8x first and then plus 3. Please do not combine those together. They are not like terms. This negative 8 has an x, and this 3 is just a constant. You cannot combine those together, so please be aware of that. Now that I've got my negative 5y, I need to get rid of the negative 5. Notice that the negative does go with the 5, but that's being multiplied by y. So please don't think you have to add that, because really you want to divide it. So I'm going to divide each term by negative 5. Negative 5 divided by negative 5, that's 1, so I can get rid of that. Y equals negative 8 divided by negative 5. I can't divide the numbers, so I'm just going to leave them as 8/5. But I do know that negative divided by negative is a positive. So now this changes to a positive 8/5. I bring my x down, and then I can do plus 3 over negative 5. I have isolated this equation for y, which is what I was asked to do in the original problem, so I have completed this. Now you'll stop the video and work in your notes, practice problem number 3.